I made a distinct effort to not screw that up this week.
Huh, voila. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Al Williams.
This is episode 279. We'll be talking solar flares, flash cells, and free airline Wi-Fi. This week in the news, Shapeways has filed for bankruptcy, and it looks like the bad kind of bankruptcy where you cease to exist anymore.
I don't know. We were talking about this the other day. You have to wonder, did competition drive them out? Or is it just people all have printers and don't care anymore? I don't know the answer to that. We do all have printers, but I got to tell you, I see the day coming when it's going to be more like PC boards. Yeah, you can make your own PC boards and you may enjoy doing that. But do you really want to spend your time doing that when you can send off and for $2 it shows up in the mail in a week? Sometimes that's just the right answer.
One of their niches, at least with people I knew, was ability to do things in exotic materials that we can't, right? So they could do the sintered metal printing and other stuff like that. And I always thought that was such a neat business model because, you have a bunch of hobbyists who can do all the 3D printing in plastic on their own and then prototype it, make sure it works, et cetera, and then ship it off to them to get it made metal. I thought that was kind of an ideal workflow, but like you said, there's kind of enough competition doing the same thing now that maybe that's what.
Super inexpensive. So I was ordering some PC boards the other day, and of course they now have 3D printing. And I went to see how much it would cost to have a little belt holder printed in aluminum. And it turns out it's got too fine a detail, so they bounced me on design rule check. But it was cheap. If they had been able to hit the resolution, it was going to cost me 10 or 12 bucks to have this, size of a middle finger bracket printed out in aluminum. And so it's pretty hard to compete with that. You have to wonder, too, not that I'm a business guy, but you wonder if they were a victim of falling capital costs, right? So if I get in the market early and buy my $10 million metal printer that's now worth $800,000, and I'm making numbers up, obviously, that puts me at a big disadvantage because I'm still paying interest on the $10 million machine. My competitors have bought the $800,000 machine, and it's probably better anyway, right? So just because things keep getting better and better. It does make you wonder, though, is there a advantage to getting in early anymore because of things like that? Maybe getting in too early is just as bad as getting in too late, and there's actually some sweet spot to get in.
There's kind of first mover advantage, but if you're the trailblazer, all these costs that you have to surmount, the companies that kind of follow on your coattails won't have to. And that's true too, I think.
I was very surprised. I did an article a while back where, some company is selling the filament with the metal powder in it, and it's very well controlled. So you print at, 10% bigger on 2 axes or whatever, and then you ship it to them and they put it in some nitrogen oven at 20 bazillion degrees, and, you get your stainless steel panda out of it or whatever it is you printed. And I'm thinking, why would I do this, right? If I'm going to, if I'm going to have to send something away to get a metal print back, I'm just going to send you the files and let you do it. Why am I going to bother printing it? Now, like you said, that's what made me think of that. Like you said, maybe I'm going to print the plastic piece and make sure, for example, this morning that my holes that are supposed to be 40 millimeters apart aren't 42 millimeters apart. That's a true story from this morning. But once that plastic piece is golden, I no longer have any interest in making something I have to send away in the mail to get a metal piece back in the mail. I just want to hit send like I do a PC board now, and the thing shows up in the mail. Why do I care? So I thought that was a weird business model also.
And the real weakness in that one, of course, is that the dimensions change, right? Like when it gets fired, it shrinks by 5%, 10%, whatever it is. So you don't even have the advantage that you can try it out and make sure the fit's just right at home, because you can't, because you'd have to shrink it. So you do have to go through this iteration procedure, and they know their process better than I do. Why do I want to adjust for their shrinkage? Let their engineers do that. They do that every day, all day, right? If I say I want it 40 millimeters between here and there, I want you to make it 40 millimeters between here and there, not me to have to make it 44 and hope for the best.
Exactly. And, if you listen to the promotionals, because I haven't tried that, it's very well controlled. And I think that's why they have the nitrogen oven and all that, is that controls makes the shrinkage repeatable. But Like you say, I don't care. If I can't just print it and pull it off the printer and use it, and I have to send it away, then you do it. I'm happy with that.
These process deals are not my problem.
Exactly.
With no possible good segue whatsoever, I wanted to mention that the Hackaday SuperCon call for participation has been extended by a week. Probably open secret. We usually extend it by a week. We've done it, I think, every year that there's been a SuperCon. We've extended the call for participation by a week. This is just between me and you podcast listeners. But we won't extend it by 2 weeks. So this is your last weekend. Last weekend was your last weekend, but this is really your last weekend. So if you've got a talk you want to give, I'll throw the links in the show notes. Form to fill out. Basically, just give us your abstract and your name, and we will take care of the rest. We'd love to see you there. And the rest of you, tickets will be going on sale in a few weeks, probably. Haven't got that date 100% finalized, but keep your eyes on Hackaday if you are interested in getting early bird tickets.
Can we infer something about the procrastination of hackers through that, Elliot?
This is a journey into sound.
What's that sound?
What's that sound?
And that brings us to What's That Sound? This is a listen to a brand new sound and guess what it is week. So, Al Williams, roll the tape.
So it's obviously something on shortwave radio, it sounds like, maybe at two different filters, because some of it sounds wideband and then it narrows down, then it gets wideband again, and there's this very distinctive water dripping noise in it, but I could not figure out what it was. I was thinking it was one of these research projects in the upper atmosphere, but I don't. That doesn't seem to be the case. I don't know. It was very short. Over the horizon radar, something in that neighborhood, but I don't have an exact answer, just a wild guess.
That's not too bad. I'll give you one clue. The higher pitched ones are the same as the lower pitched ones, just played a little bit faster so that the kind of blippy noise sits better in human hearing. The lower pitched ones are real speed. That's actually real time for this signal.
I do not know. Maybe whisper beacons. Who knows?
None of the above, but we'll have to throw it out to our listeners. If you know what the sound is, or just want to take a wild guess, head on over to hackaday.com/podcast. Scroll on down to What's That Sound, and you'll find a form to fill out with your guess and your handle. And next week, when we have a drawing among the correct answers, if the random numbers pick yours out of the hat, we'll get you a Hackaday podcast t-shirt.
And my service is that your guess can't possibly be worse than mine, so you're welcome.
No, those are all good. My first hack this week comes from Robert Heaton. It's a hacky hack and kind of a thought experiment at the same time, but a devious one at that. Hacking airline Wi-Fi the hard way. Like, this is the hacker dilemma. You're stuck on a really long airplane flight and you don't have Wi-Fi. What are you going to do? One possible answer is just, pay the money and get the Wi-Fi. And the other is waste your entire flight making this entire cockamamie protocol to smuggle data across the one thing you can get to on the airline, and that is the Jetstreamer's Diamond Altitude account enrollment page. So basically, this is transmitting your data across the name field for an Air Miles account and picking it up. And the result is called Pi Sky Wi-Fi, which is a fantastic name. Part of the reason that this was more of a thought experiment is because it involves setting up a ground station, first of all, before you get on the plane, to periodically hit your Air Miles account and see what your name field says, and then put more data back into this name field, while you, flying in the sky, can change the name field to send data to the listening computer on the outside. His implementation here is that he sends basically encoded HTTP requests to it. His listening computer then goes and fetches the web page, encodes it back, and then sends it back to him across the name field. It's pretty funny. It definitely shows you what happens if you know a little too much about networking and how they work, because once you realize that any small like hole that you can put data through can be made to resemble a normal network, you're tempted to do it. And that's exactly what Robert did here. It's absolutely hilarious. Like implementation details that you really care about are encoding all of the data in base 26 so that it looks like normal characters, because, you're filling out the name field of an air miles thing, right? It can't be, quotation marks and parentheses and things like that. And besides, if you do something too crazy, you're probably going to drop tables them and ruin their database, and then you'll be in real trouble. But it also has a little bit of a header encoded in there and breaks the data into packets, puts them in order, the whole usual networking deal over the name field of your frequent flyer account. Pretty funny.
Well, this will teach me to not start the podcast spreadsheet myself, because I was going to pick this one. And you got to it before me. But, the couple of things I did think I gave credit to Robert for. I mean, first of all, like you say, great hack. But the other two things that I thought were really impressive, one was that he didn't actually do this, right? He proved he could do it, and then he developed the prototype on, I think, GitHub or something, where it just dumped stuff in a gist and then got it back out. So he wasn't actually, or at least that he'll admit to, he wasn't actually doing it with the airline. The other thing that's really impressive is that he thought about doing it in Go, and then when he realized he could call it Pi Sky, if he wrote it in Python, he switched gears and wrote it in Python. And I thought, well, that's one of those things a normal person would say, are you out of your mind? And I'm thinking, yeah, I get it. That's perfect. I would have done the same thing. So good job on that for sure. It is interesting though, once you see that all these things are out there, it becomes a game of cat and mouse, right? So I could just see some airline IT security guy reading Hackaday and going, now we've got to stop this. And of course, easy thing to that would be, don't let people log in more than one place at a time, right? So if the ground station logs in, the airplane can't log in until it logs out, vice versa. That would at least slow it down to be even less usable than it probably is already, right? And I'm sure there's some other countermeasure. One name change a day or something would be another idea.
Yeah, Robert suggested that one way they could beat this is to put a delay in the name field, because he tested it and could change his name in rapid succession. So,
Yes.
This isn't as bad as you might think. He can just go changing it over and over. And worse, he can expand out to a few more fields too. If he needs to get, a bigger pipe, he can change his address or his date of birth or whatever, right? So there is a way to expand on this if you were actually going to do it. But I think it's really just a funny proof of concept thought experiment anyway. But what isn't, and what this reminded me of, was the old trick of putting your data out on DNS requests. So, if you have a Wi-Fi access point that you can't log into, but it will nonetheless do a DNS lookup if you type an address in, people used to get data out that way. And I was thinking about it, and nowadays with all the captive portals that do address rewriting and kind of a local DNS, I wonder if that even works anymore. If anyone's tried it, the kind of data over DNS trick, head on over to the comment section and let us know. I'll throw a link to some now 8-year-old article getting the data out over other people's Wi-Fi. But if Wi-Fi is old and busted, the new hotness is, of course, AirTags and the brand new Android equivalent. And these are interesting too. I know that the Open Haystack people figured out a way to set at least one status bit in the Apple AirTags report, which means that you can use that as a free network anywhere you want to send, I think, 1 bit at a time. It's not a very high rate, but I wonder if people have started looking at the new Android device location services, and I haven't read anything about it yet, and I'm interested to see if you're hacking on the Android where's my phone thing and can do anything useful with it. Let us know.
I saw an article the other day where they put one tag of each type in a box and mailed it somewhere. And as you might expect, the Apple one was much more resolution of tracking, just because there's a lot more places that receive those today. The Android one was like, I'm here, now I'm 1,000 miles away, now I'm back where I started because I lost track of where I was, because there's just not that many places for it to touch touch base yet. It was interesting, though, and I think I put that in link in this post. Someone has done a similar airline hack before because a lot of the airlines will let you use iMessage or WhatsApp for free. And I'm not sure why WhatsApp is a big deal, but you can't use like Google Talk or Google Chat or whatever they're naming it this week. But you can use WhatsApp. So that's the only reason I have WhatsApp on my phone is if I'm on an airplane and I want free texting. That's how I get it. But you could easily, and someone has done this, you could easily do this same kind of tunneling idea where you have a WhatsApp robot sitting at home and you pass it packets and it passes you back packets and you just do the same kind of thing Robert did. So it's a lot of different ways to, well, I hate to say skin that cat because we'll probably get mail, but a lot of different ways to solve that problem in a responsible manner. There we go. Well, my first hack is from, I'm going to say George. It's got a 0 in there, but I just can't figure out how to do G0org and make it sound right. So it's from George. It's really a classic thing that we've seen quite a bit of is Samsung cameras had some feature where they could instantly send your messages to, social media. And Samsung decided they were tired of supporting that, so they pulled the plug on it. We see this all the time, right? Oh, you've bought this wonderful cloud device. Here's a bunch of features you bought it for, but we've decided we didn't realize that was going to cost us money, so sorry. The answer in this particular case for George was to get a $20 little dongle that's essentially like a Raspberry Pi Zero sort of computer that happens to have an LTE cell modem on it. And if you can figure out the protocol, there you go. The trick here is it got me thinking about, should we be planning for this? And maybe should that be a sales point that you say, oh, we're going to put the API in escrow. And if we ever decide we're going to go out of this, we'll release the source code and, the escrow company will release it. We're not going to just hoard it. That would stop people from having to reverse engineer all this stuff because let's face it, most people who have these Samsung cameras don't have that option, right? They're not going to be able to say, oh, let me get Wireshark or whatever it took to do that and go figure it out. But it also would allow people to say, Samsung abandoned 800,000 users or 80,000 users or 8,000 users. Maybe 8,000 users is nothing to them, but, Elliot, to me and you, that would make a good business if we were supporting 8,000 people and could get $5 a month for them. That's a side business, right? If you had that kind of escrow arrangement, it would give people more options when when Big Brother decides to take his toys and go to the next product and spend their money there. I don't know if we'll ever see that because I just don't know if there's enough awareness of it, but it seems like that should be a thing.
I think there's something about this, though, that wants to be a bit of a bespoke solution. And so that's why I think the kind of hacker version of this is better anyway, because say George doesn't use MySpace anymore, but nowadays he's on Mastodon, right? That means Samsung's going to have to rewrite their entire software backend so that it uses this service or that service. Where you want to post your photos to and how you want to post them is actually kind of a personal thing anyway. So it really makes sense for this to be in the hands of the hacker like it is with his software here. And I think that's awesome. And it doesn't even have to be a social media service. You could write this backend so that it posts photos with a small comment or something up to a blog that you own. And actually, that's something we did in my old hackerspace. We had if you were in the space doing something, you could just take a picture of your project in progress and send it to, well, we had a server running. And so you drop it in this folder on the server with a comment, and then it would post it automatically to our Hackerspace's blog. And that was really cool, just as a kind of a, DIY micro publication framework. That sort of workflow, which is exactly the workflow here, is in practice just so pleasant that you just be like, take the photo and then it posts up, if you want it to, is actually really cool. And so I think that part of this project is super cool. Jenny picked up on this device, which is basically an LTE modem that's very hackable. And so you can put your own operating system on it. In this case, I think he's got Debian. That's pretty cool. What's funny is I went looking for it. I was reading his post and he mentions that it's a hackable $20 modem, combines LTE and Pi Zero. And so I click on that, and of course it's a Hackaday link and, eating our own dog food.
Well, do you think we could get George to give us a back end for Hackaday IO?
Exactly. See, how awesome would that be if you were doing projects and you could write himself one? Yeah, totally. That would be super cool. for instance.
So if you're listening, George.
All right, my next hack is a talk, actually, from Tom Lodchowski, SuperCon 2023, Why More Hackers Should Earn Their Wings. And this is one of the talks that was going on the Design Lab stage, so hasn't been seen. So if you thought you saw all of the SuperCon talks, this is a new one. Go check it out. It's basically Tom talking about experimental amateur-built aircraft and what you can do to get into that scene if you want to, and what the advantages of it are, and etc. And it was really kind of a cool look into not just like amateur aviation, but like the hacker side, the experimental crazy side of amateur aviation. It's funny because the rules for normal certified planes are, of course, very strict and all of that. And then there's a category for planes that have never flown before and planes that you're just trying out and you don't even know if they're going to fly, and etc. And these are experimental and amateur built planes. And the rules are exactly the opposite. Like, you have to be able to document that 51% of the build of this airplane was your own labor. He mentions this while talking about, the ability to get plans or even kit planes on the internet. All the kits are designed so that they provide only 49% of the plane, and you have to provide, the other 51% of the worth, value, and investment in the plane, which I think is pretty cool. He mentions the big annual experimental airplane builders meeting in Oshkosh and some of the other benefits that you can get if you go down this path. I think the one big limitation is that you do have to get a normal pilot's license, and that ends up, I think the worst of it is that it ends up requiring 50 to 70 hours of flying time with an instructor, and that can cost like $100 an hour. So 150, he says, even. It can be super expensive, and that's what's going to keep me out of the piloting business. But as a number of people point out in the comments, you can get up in a glider for dirt cheap, for $20 in a day if you want to. So if you're interested in poking into aviation, find a local glider field. That's really awesome. Anyway, the final virtue of getting your license and starting amateur building stuff is that it opens up the Special Certificate Experimental Unmanned Aeronautical, what's the A there? Systems. So you can fly long distance drones and heavy drones if you get a pilot's license, as well as kind of a knock on. It becomes extraordinarily easy to get this extremely enabling drone license. So I think that's kind of cool too.
Enabling, that's a good choice of words, yes. Well, it's interesting. I agree. I mean, I've known a lot of pilots, both commercial, military, and just general aviation pilots, and it's a lot of fun. A lot of my friends are pilots. They always say, hey, you should do that. And I'm thinking, well, A, I'm not that coordinated, but B, I have enough expensive, time-consuming hobbies, so I don't really need another one. But I have flown a lot with them. And, there's a lot of things. I think it's like ham radio, right? There's a lot of things that you can do. It's not just, I get up and I fly, right? Some people do different experimentation. Some people, like you say, build a lot of experimental stuff. People fly sick children to hospitals. There's, the angel flight people, which I always thought that was really cool. Just like some hams do disaster recovery, and some do contests, and some do, so there's a lot of areas in there to work on. And a lot of it is compatible with things you'd want to hack, right? Just like ham radio. So I think it's a cool thing. I will say, a guy I knew not too many years ago, he and his dad liked to build RC planes, and they decided to build an ultralight. And on the maiden flight, he was up, I think, almost 200 feet. He stalled. The intuitive thing to do when you're falling is to pull your nose up, but of course that's the wrong thing to do when you're stalled, right? And so he literally fell from the sky, and he was very badly injured. A lot of work to get him back to, I'm talking years of effort to get him back to kind of close to where he was when he started. So if you do this, please be careful, and please make sure you know what you're doing, but it is very doable.
Absolutely. This is kind of one of those other passions where the hacker mentality fits like hand in glove with it, right? Like you mentioned ham radio, but like last week we had these guys who were trying to solve some unsolved disappearances and ended up building some really neat, underwater rovers and things like that. There are, like you mentioned model airplanes, there's all sorts of fun techie things you can do there. I mean, that's a super hacky pastime. Like there are all these kind of additional hobbies that the hacker mindset fits superbly into. And I'd never thought of flying as being one of them. I think partly because of the danger aspect of it that you mentioned. Like you really don't want to go up in an unairworthy aircraft. And I think that takes more of, the engineer mindset, the cross all the T's, dot all the I's mindset, more than the just like YOLO hacker, this is version zero point 0.1 mindset. If you can put on both of those hats, it's probably extraordinarily rewarding. And I don't think I'll ever build a person carrying airplane, but I would totally want to go to like the experimental airplane builders convention and just see what all the crazy stuff is that people are working on.
My next hack was from Fiz Cavity Filters, the black art you have a chance of pursuing. I've been a ham radio operator since I was like 14 years old, and I will give you a hint. I'm nowhere near 14 years old now, almost 50 years of being a ham. And RF still strikes me as black magic. There's no doubt about it. And it's stuff like this that really makes you think that, it's one thing to say, well, there's a transistor, it amplifies some stuff. I mean, even a coil, capacitor. But this is like a box, right? A box with some tubes in it. And I don't mean vacuum tubes. I mean like cylindrical pieces of metal tubes. But it acts like a quarter wavelength piece of coax, And actually, there is a good reason. Fiz does about as good a job as you can do explaining intuitively how that's supposed to work without getting into all the math and the, Maxwell's equations and curl and spherical integrations and all this stuff that pretty quickly lose people. But what a crazy idea. And you got to wonder who figured this out, right? That's what I'd really like to do, is dig into the history of who was the first person to go, oh, I bet if I built this box, this particular dimensions, it would filter out my bad frequency. These used to be super common. Well, Jenny mentions they used to be super common in TVs. They also used to be super common on like 2-meter repeaters where you would have duplexers. And, that's more magic, right? It looks like a 6 or 8 aluminum cans put together, usually made out of copper though. And coax goes in one, coax goes in another, coax comes out the other, and you can share one antenna with a receiver and a transmitter as long as they're separated by a couple of megahertz, and how does that work? Well, it works through the same kind of things here. And it really has to do with the fact that the radio waves are literally waves. They've got a certain wavelength, and all these physical dimensions actually cause fields to be generated that do or don't do things you want them to do. It's just amazing. I'm always just stunned when I see stuff like this. So if you've not had the pleasure of digging into those sort of contraptions, this is a pretty accessible video. I'm not sure you're going to go off and be the, world champion designer of cavities after this video, but you'll know a lot more about them.
Yeah, it's kind of like designing a pipe organ or something. I mean, it really is these standing waves in a space that are doing it and picking out some frequencies and minimizing others and stuff. You pointed out that you used to see more of these is probably true, and that's probably because frequencies used to be lower and these devices used to be more macroscopic. Nowadays, I think there was an article last week about a 5-6 gigahertz radar device, and it has a bunch of these kind of, strange black magic radio components where, a capacitor is just two traces that are next to each other, and an antenna is a funny triangle shaped piece of copper. That stuff is all very physical and very kind of real. Like, this is how waves reflect off of things. It's just the wavelength there is so much smaller that it all fits nicely on a PCB, whereas these are in comparison, gigantic, even though I think they could sit on your desk. Similar structures to tune for this frequency or knock out that one.
Well, you mentioned you were very interested in like the design of music halls and stuff, right? So maybe this is just the RF version of that.
It's just the same thing. It's a little copper room, right? And the waves bounce all around. Put your frequencies in the little copper room. Well, my last hack this week is a video from our own device's candle-powered lantern isn't as silly as you think. And on the face of it, I guess it is silly, right? Like, it's a candle, and then this goes through a Peltier generator to then make electricity to light up some LEDs, right? And so that sounds ridiculous that you would have a candle-powered LED, especially passing it through the source of all hacker tears, the Peltier element. But it turns out to be not ridiculous at all. And what I really liked about this video is he breaks down some of the efficiencies for you here. And so he says if like a tea candle gives off about like 80 watts, almost all of that is heat and about 0.05% of that is light. So if you think about a candle or indeed an incandescent light bulb, I'm still shocked that they're about 4% of the energy in light and 96% of the energy in heat. Candles give off 99.95% heat. And so if you're looking at a candle as a source of light, you've got it all backwards. It's a source of heat for your thermocouple to generate electricity to turn your LEDs on. I don't think this is a reasonable device, but I think it's an awesome device, and it gives him an excuse to go through how Peltier elements and thermocouples in general work. Basically, you pick the two elements that have the most willingness to give up their electrons when heated and receive them when heated, and you jam them together, and then you heat this junction and the electrons go from one side to the other, and boom, you've got a current. And that's the Seebeck effect, I guess. It's the opposite when you wait, I can't remember which way is forward and which way is backward.
The Seebeck affects thermocouples, and the Peltier effect is the heating. They're inverses of each other. Yes, as opposed to the thermocouple where you put heat on one side, cold on the other side, and you get current, right?
That makes these thermocouples because the thing has a kind of set of fins that go around where the candle flame's going to go on one side, and then outside of the kind of candle lantern body, it's got another set of fins that are trying to be the cool side. And it's this hot side, cool side that makes the electricity here. One last funny detail in this particular lantern that I thought was cool, which is that it tries to trap as much heat as possible inside the candle lantern by using a bimetallic strip that opens and closes depending on how hot it is in there. So it opens up and lets some air in, and then it closes up and keeps the heat in. And then when the candle starts dying because it doesn't have enough oxygen, it cools down a little bit, and so it opens back up. And so it's kind of a weird bimetallic strip, purely mechanical temperature regulator. I think that's really lovely. Anyway, he estimates that, if the Peltier effect is kind of 6%, 10% efficient, and that, maybe 75% of the heat from the candle gets out of there, still, that means the LED powered side of things is looking at 4% efficiency, which beats the heck out of the candle by itself at 0.05. So maybe this isn't crazy.
I really enjoyed this myself for a couple of reasons. It really reminded me, and I put a link in the show notes, of how the Russians had, for like far-flung areas of Siberia or wherever, radios that had a ring that were powered by kerosene lamps. So you put the ring on your kerosene lamp, which you had anyway, that picked up the heat from that and was enough to run like a little transistor radio. And honestly, that's what always gets me about the whole Peltier effect thing. Those Peltier modules were exotic in the 80s, and outside of like high-tech aerospace were almost unheard of. And back in the 80s, I worked for a semiconductor company. They used to cool parts down with Freon going under a chip socket with a pipe. Well, the problem is when you put it under a microscope, the thing would vibrate like it was having an earthquake, right? Just from the Freon going through it. And I'm thinking, when I was a kid, I read in Popular Electronics about, all I could remember was thermoelectric heat pump. Of course, no internet in the 80s, so I schlepped to the library. I find Popular Electronics. I dig through, 5 years of back copies, find the article. Then I had to go to the Thomas's Register and find the one company that was making these and talked to the guy he was, I think, in New Mexico. He was in New Mexico around White Sands, and he was like the expert on them. And he tells me everything I need to know and actually sent me one. And we built this system that cooled the chip down with the solid state heat pump. But everybody I had asked at that point, I said, have you ever heard of that? Everybody would say, no, I've never heard of that. What are you talking about? I think you made that up. So the internet is so awesome because now they're very common. But even if you didn't know about them, 5 minutes and you can know everything there is to know about Peltier effects and Seebeck, Russian radios. I mean, how cool is that? So
I love the Russian radio device. It makes me wish that I had to heat our house with like a log stove or something, and then I could make up crazy thermocouple devices to power our house with it as well. But sadly, central heating.
they could stick them behind the solar panels, right? They probably get hot. They're wasting a lot of heat there.
Actually, we've got radiators. Huh.
Yeah?
Yeah, you could put things on top of the radiator.
There you go.
Oh, that'd be an awesome Hackaday challenge.
What can you power with waste heat? I like it.
Bring out the Stirling motor, folks.
My next hack is from Cody. Actually, it's Cody's lab, but I assume that's Cody. The Thermite Process Iron Foundry. And I got to tell you, I never really thought about that. I mean, thermite, if you are uninitiated, is aluminum and iron oxide, which has a delightfully exothermic reaction and produces aluminum oxide and iron. And you say, well, I can already get iron. Yeah, but it's so hot, you get molten iron. That's pretty impressive. So it makes it a little easier to do smelting if the chemical reaction's already making it hot. It kind of reminded me a little bit of the article I did. I think you talked about it last week, where I wanted to make an X-ray machine, which would have probably killed me in a particle accelerator. You always saw these ads, and I could not find one. I searched through the World Radio Archive or whatever, and I could not find the ads, but there were always these ads in the back of the magazine about make thermite, melt down engine blocks. And I'm thinking, yeah. And I'm thinking, I don't know why I was interested in melting down engine blocks, which I did not have, to 11-year-old or 12-year-old. It just seemed like something that would be very cool to know about. And I never sent away for the thermite plans, but obviously Cody did and used it to make a skillet. I don't think it was the finest cast iron skillet ever, but for a homemade one, it was pretty good. I don't know, that's another thing like the flying. You probably shouldn't be messing with thermite unless you're pretty sure you know how to mess with thermite. But if you were going to melt down iron anyway, you probably should know what you're doing. And this is certainly a convenient, easy way to produce molten iron.
No, this is just the craziest video. And, if you think people would say, why are you burning a candle to make LEDs light up? This one is, why would you be playing around with thermite when you could just buy a cast iron pan? And the answer is because it's so much more awesome to make your own cast iron foundry.
Lodge has nothing on Cody, that's for sure.
All right, well, my first quick hack this week comes from Jack Ells and Peter Ells. This is a father and son project from way back in 1998. It is celebrating the Jack Ells Automatic Photometric Telescope. It was a sweet telescope run by a BBC Micro back in the day. Its output was passed off to a photomultiplier tube through a little pinhole, and it tracked a star across the night, and the photomultiplier tube measured and recorded the star's brightness all the way across. There's all sorts of neat detail here about how they kept it centered and stuff like that in kind of simple 1988 fashion. Really great build, and another reminder that astronomy is one of those hobbies that definitely rewards the hacker mindset. A video from Alec at Technology Connections, Plight of the Lowly Pneumatron Tube. The Pneumatron is kind of the lesser, what is it? It's the younger brother of the Nixie tube family. It runs at lower voltage, and it's basically a 7-segment display made up of light bulb filaments. Alec takes exception to the kind of janky build and not very nice number shapes that you can get out of these. But at the time, it was replacing, Nixies, which required 10 wires plus another. Instead here, of course, you can do it with 7 and a lower voltage. So it was, quote, technological progress that was fortunately very shortly afterwards eclipsed by the LED. I think Alec probably has a little bit of the OCD going on, worrying about the way the corners of the numbers mix up. And then I'm sitting there looking at his Nixie tubes in the background. And he's got the ones where the 2 is the 5, but turned upside down. And they like cut the corners on that so hard that they're like, we're just going to use one stamp to do the 2s and the 5s. Don't throw rocks if you live in glass houses. And last up, Nate Sales, repeatable one-click fusion from your cell phone. This is partly a software suite to control a Farnsworth fuser, but it's also a really neat look into what goes on if you are interested in running your own fuser. Basically, this is you take some deuterium and some high voltage and you smash it together. It's not a I'm going to be making excess energy kind of fusion, but if you need a bunch of neutrons flying around, it at least gives you that. And because of that, you might want to be remotely operating this thing. And so Nate's cell phone control app is exactly what the doctor ordered.
Yeah, another good project for an enterprising 10-year-old, right?
A 12-year-old is the youngest.
No neutrons
fusioneer.
before 12. Yes, that's right. Yeah, that would have gone real well with my X-ray tube and my particle accelerator.
It would have.
My arc furnace, which I did build, and my Thermite engine block meltdown. So, yeah.
Except these days, there's so much of this information out there that I do believe you can do it, carefully, safely, and correctly. I don't know about 12, but
I was going to say, not me at 12, though. I'm sorry. Maybe in my 30s, I might have gotten away with some of that. But, well, my quick hacks. Another maker. I had to call this one out. The actual post is bringing the 555 mini notebook to video. So Radio Shack had the Forest Mims books that had all the little circuits in them, and that was one of the more famous ones with the 555 timers in it. So this guy went in and made all the circuits in the book. And what he wound up doing was, instead of doing them on a breadboard, he had PC boards made. I think he had 4 projects per, because they're all little things meant to be made on a breadboard. One of the things, first, it's a cool idea, but second of all, sadly enough, our own Dan Maloney had the same idea of taking the Forest Mims books and doing them as a series for Hackaday, and I guess didn't get around to it. So now we're late to the game. But I guess it just goes to show you can't have a good idea all by yourself. But it is a good idea, and it's fun. All this old stuff, you think, it's old stuff, what do I care? You'd be shocked how many times you can go page through like an old Popular Electronics or Electronics Illustrated and see something and go, oh, that's an interesting idea. Maybe I should, yeah, you probably can't get the parts and, you probably would do it a little differently, but there's a lot of information in those things that will spur off things. Same thing here. How many different ways can you use a 555? Well, probably more than 555 ways to use a 555. I know it's not the same as aviation hobbies, but VA5MUD is going ham mobile on a bicycle. And so the idea of operating 160 meter HF on a bicycle just kind of amused me for some reason. Interestingly, though, to bring it back to aviation, one of the contacts he made was with a pilot flying, I believe, a 737, and he had a ham radio license. I guess he just moves the radio over to the ham bands and uses it. I'm not sure what the legality of that is. And so you had a bicycle to airplane QSO on some band. I don't think it was on 160 meters, but according to the post, he can in fact do 160 meters. If you aren't radio savvy, the bigger the wavelength, the longer the antenna. So even people in large yards sometimes have trouble getting an antenna that works well on 160 meters. So congratulations to VA5MUD. And last but not least, just for you, Elliot, they had the RISD, I guess, RHYSD, RISD, had the C compiler written entirely in Vim. So it actually uses Vim script, and it's a C compiler. And before you get too excited, it takes 20 minutes to compile Hello World. So, it's not really anything you would want to use. But I was thinking to myself, well, this would have to be easier in Emacs because you got eLisp, and Lisp is really good at doing parsers. But, I searched around. I haven't found anybody who did that. So I think I'm going to throw down the challenge. And I think somebody needs to write me a C compiler in eLisp, and we can have a showdown. So
I like Vim. Vim script is its own horrible hell. Well, that brings us to our can't miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. And this week I picked Dan Maloney's Solar Dynamics Observatory, our solar early warning system. And Dan is kind of our resident sun spotter, if that's a word. He really likes to follow the solar flares and their possible consequences, but also what they do to the ionosphere for radio purposes. And in this case, he tipped me off to some of these absolutely amazingly beautiful videos that are made by the Solar Dynamics Observatory. And if you haven't seen them, it will give you a new appreciation for the sun and its dynamics. Anyway, go check that video out when you're done listening to the podcast. We've got one of them included in this article. The rest of it is just talking about what the SDO is. It's a satellite observatory looking at the sun in a bunch of different wavelengths. It's got a wide camera that gives you a whole view, and then it's got a thin cameras, and it's got various filters that it can put over so that it captures different wavelengths. And I guess it originally was designed to discover some of the magnetodynamics going on there, and I was trying to figure out how that worked out, but it turns out they just use a polarizer lens over one of the cameras, and so they kind of infer magnetic dynamics from the polarization of the light that comes out of it. I was a little disappointed, but I learned that this was all the result of a project called Living with a Star, which is the awesomest name for a let's go learn everything we can about the sun project. The other thing that's cool about SDO is that, you might think that if you wanted to put up a satellite looking at the sun, you'd get it away from the Earth and maybe put it at like the Lagrange point where the Earth's gravity and the sun's gravity are kind of equal out on it. So it could kind of follow the Earth around. But because this is also a super data intensive project, they actually put it in a geosynchronous orbit and actually built a couple of special receivers for it in New Mexico. And so the orbit's geosynchronous, but it's inclined. So it kind of goes, you can kind of think of it, if you're looking on the Earth and looking up to it, it kind of goes up and down across North and South America with us. And because it's at this really weird angle, it's almost always able to see the sun and absolutely always able to see its ground stations. And so it was kind of optimized instead for the ability to get data down to us rather than the ability to see the sun for exactly 24 hours. I think it's got like a small blind spot every day. I didn't know any of this, of course, before reading this article, so that's absolutely lovely. The Joe Kim artwork at the top, you got to check that out. I was like, here's some of these videos, Joe, do what you want. And he was obviously inspired by them because it's a beautiful like ball of flame sun with the satellite silhouetted. Pretty sweet.
It's amazing that, the sun's 8 light minutes away, and it's truly enormous. I mean, I think you forget just how big it is. And it has such an effect on us. But most of us don't really think about it a whole lot, outside of Dan, perhaps. Do we know it's not going to just suddenly balloon up by a factor of 50 and kill us all? I don't know. Hopefully somebody knows. Interestingly, if you want to follow more on the sun, we've talked about the Zooniverse before, and they occasionally have sun-looking projects. So I put the link in the show notes, both for an article on Zooniverse, but also the Zooniverse link to Sunspot Detectives. And so that's that project that they use to get citizen scientists to analyze data. So even though I don't think the Solar Dynamics Observatory data is participating in that, at least not today, there are lots of opportunities. If you want to make observations of the sun, that's actually fairly easy to do. And even if you just want to analyze other people's observations of the sun, there's a lot of avenues to do that. So something to think about if you are interested in exercising your citizen scientist chops.
Oh, and speaking of the SDO data, all of it is available to the public. It's all up on this NASA website. I think it's the last link in his article. You should definitely go click there. I mean, if you just want to look at really cool pictures of the sun, they've got that. But then if you want the raw data for any and all of it, it's all up there. And it's something like 1.5 terabytes a day of data about the sun. So, you got your work cut out for you if you want to do something with this. But, there it is if you do.
Well, that's why I suggest Zooniverse is they kind of organize it and give you some kind of, they don't just say, here's a bunch of data, go figure something out. They'll say, here's some pictures. We want you to count the number of sunspots. This is what a sunspot looks like. these are not sunspots, and then you kind of go through that. You do your
Cool.
counts, or
I like looking at the pretty pictures.
they are pretty. Well, my pick this week was Maya Pasha's The Flash Memory Lifespan Question, and there's some subtitling to that. I understand flash memory because it's basically like EEPROMs, and I've worked with those many years at the die level. They just kind of have gone a little more sophisticated. So EEPROMs trap a charge on a gate, and with an EEPROM, traditional EEPROM, you used ultraviolet light to get those electrons to go away, or the charge rather to go away when you didn't want it anymore. Then they had the electrical erasable versions, and then flash memory is kind of the evolution of that. The problem is reading all those little charged gates in and out of places. And so one of the things they do is they decided they could get better density by not just storing data in a gate, either it's here or it's there, it's trapped here or it's trapped there. They now trap them in different zones. And so that's good, but it makes them less able to withstand wear. And it also makes them slower, and Maya talks about all that. And so there's the difference between NOR flash and NAND flash, which I have to admit I did not understand till I read this. So it's one of those things, if you're real dyed-in-the-wool on modern flash technology, this probably doesn't tell you anything new. But if you're like me and just have some vague idea of what flash looked like 20 years ago, this was a great post and had answered a lot of my questions.
Well, that wraps it up for this week's Hackaday podcast. Thanks a ton for listening. If you want to follow the links or drop us a comment, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, shoot us an email, tips@hackaday.com. And until next week,
Keep those hacks coming.
but if Wi-Fi is the old hot, the old... and how am I going to pronounce that now? Smarty pants.
Yeah. Well, now that's your problem. I did my part. I pulled off my miracle, Elliot. You pull off yours. That's a wrap.
Happened so suddenly I didn't even see it coming.